So a student asked me some questions about solving exponential equations online, and so I creating this video for that individual, but of course it's helpful for everyone, so I'm going to post it, of course, and share. My initial response, because the questions were via email, the initial response asked the following questions to try to prompt and create some thinking around it. So I asked this question: if I have these this left-hand side and right-hand side of this equation, since the bases are the same, I can either think of it analytically by taking the logarithm base 7. So I can take the log base 7 of 7 to the 2x and take the log base 7 of 7 cubed. So I'm taking the log base 7 of both sides. Now if I do it the long way, I know that I can take this exponent and write it this way. And the same thing with the 3. I should write this a little neater. And this is kind of the long way to think of it. It's not incorrect in any way. It's actually more, if you wanted to create magnitudes of correctness, it's probably more correct to go through all these steps. And then I know that this and this are equal to 1. Or if you didn't even know that, that's a number being multiplied times 2x. I could divide both sides by that number. Happens to be the number 1. But since we know it's the number 1, I can write it this way. And then to determine this original value of x, I'm going to divide both sides by 2 and get x equals 3/2. Okay? So that's the more mathematical way to go through that. But as we get used to certain mathematics and ideas, we start shortcutting things, which is not uncommon, as long as we understand there's math behind everything. So when I think about it, I can look at these two powers and look at the bases as being the same. If those bases are the same, then for these two powers to be equivalent, then their exponents have to be the same. And if that's the case, I can write it that way. And so this is more of a logical way to look through it. And then I can divide both sides by 2 and get x equals 3/2, and we get the same answer, right? So I posed that question, didn't hear back, which is perfectly fine. I'm not ripping on anybody. And then in the same email, I asked the following question to work on this idea: 2 to the x equals 1/2, because the problems that they asked about incorporated this idea. So we have to think about it. Now, oftentimes in math, we're going to take something that is unfamiliar or more complicated and make it look like something that we are more familiar with or is less complicated. So this 1/2 fraction looks more complicated, and I also want to represent this 1/2 such that it's a power with a base of 2. Well, hopefully we know that 1/2 can be written as 2 to the negative 1. And if I can do that, that's a power with the base of 2. And so I can write this as 2 to the x. And since these two things are equivalent, I can substitute this in for that and say 2 to the negative 1. Using the same logic, or if I want to do it analytically, raise both sides to the logarithm base 2. But if these two powers are equal and these two bases are the same, then their exponents have to be the same. Oops. And so I determined that x must equal negative 1. So now to the questions that the student asked about, the problems that the student asked about. This one here, that's not exactly what I wanted to do. That's what I wanted to do. And I think this one's the least difficult of the two that was requested. And so can I write this with a base of 16, or can I write this with a base of 8? And the answer kind of is no, not in a uncomplicated manner. You could, certainly. But what base would be common for both of these? Let's say the number 16 I can write as a number or a power with the base of 2. So 2 squared is 4, and 4 squared is 16. So I can write that as 2 times 2 times 2 times 2. This is equivalent to 4. This is equivalent to 4. They're still being multiplied, so I get 16, right? So 2 to the 4th is equal to 16. So I can write this as 2 to the 4th. Now remember, this whole thing is being raised to the exponent, because I'm just substituting this in for the value of 16. So actually, let me write this a little bit differently. I'm substituting in for this. So 16 is equal to 2 to the 4th. So I can write this as 2 to the 4th, and then leave this negative x raised on as the exponent on that now differently written or newly written base. I can write 8 as 2 cubed, right? So 2 times 2 is 4, times another 2 is 8, so 2 times 2 times 2 is 8. So I can write this as 2 cubed, and if you need to, or if you want to, this was raised to the 1. It doesn't really matter. This would be raised to the 1, which means it's just it. So now, how do I take care of these two? It's my properties of exponents, or as I call them, shortcuts of exponents. So I can rewrite this left-hand side as 2 to the negative 4x, and this would be 2 cubed. And then we're back to this idea where I have two powers that I'm claiming that are equivalent with the same base, thus the exponents must be equal. And so then I divide both sides by negative 4, and I get negative 3/4 as my value for x. Okay? Now, the last problem that the student asked about was this one. So let's scoot this down so I can be lazy and not rewrite. I know this is probably annoying. Maybe I'll scrub through it faster. I'm talking, whatever. It's not a big deal. So now I have this base, and I have this base. Can I write 4 as a 2? Yes, of course. 2 squared, right? 4 equals 2 squared. And can I write 9 as some form of 3? And I can write it as 3 squared. So 4/9 can be written as 2 squared over 3 squared, or 2/3 squared. So I can write this the same that I have here, 2/3 equals 5x plus 6 equals, and now I can write this inside here, 4/9, to be written as 2/3 squared. That's all inside the parentheses there. And this 4 exponent was still on the outer portion of that. And so now I want to resolve this so that I have a single power with the base of 2/3, a single power with the base of 2/3. So nothing's happening on the left-hand side. But the right-hand side I'm going to rewrite as 2/3. And then this is going to be 2 times 4, which is 8. And so now I have two powers that have the same base. So for this equation to be accurate or correct, the exponents have to be equivalent or equal. So that means this must be equal to 8. So I set it equal to 8 and solve for x. Subtracting 6, I get that. And dividing by 5, I get 2/5. All right? Hope that was helpful. Have a good one.